Stanford University.
Okay, well, welcome to lecture number 8 of Stanford CS 193P, fall of 2013 and 14. And today we are going to talk about a couple of Objective-C things first, language features basically, and then we're going to talk about animation. So animation is our topic of the day. I'll be starting a demo at the end, which we'll finish on Wednesday. And I'm going to demo pretty much everything I talk about, including the Objective-C things, and even including some of the things we talked about last week. So it's going to be a very big, comprehensive demo. That's why it runs over into two things. So the first Objective-C thing we're going to talk about is protocols. I hinted at this earlier in the quarter. This is a way that we're going to make ID a little more useful by making it a little safer. Okay? And we already have introspection to make ID safer. Well, we have something that's an ID. We know it's a pointer to some object. We don't know what kind of object. We know how to use introspection to ask at runtime, what kind of object are you? What kind of methods do you respond to? That's nice, but it'd be better if in our code we could document in a way that both the reader of our code can understand and also that the compiler can understand what it is we intend, okay, with that ID. What methods we plan to call on that ID. And so that's what protocols do. It's basically syntax. It's just syntax in the compiler, nothing more than that. It's kind of the same thing as string star versus ID. That's really just syntax in the compiler. That makes no difference at runtime. And the fundamental part of the syntax is right here, ID angle bracket protocol obj. So that's declaring a variable of type obj, which is an ID, but it's got this additional little thing, my protocol, which tells the compiler and readers of your code a little bit more. So let's talk about protocols and how this all works. The first thing we're going to talk about is how to declare a protocol. And declaring a protocol looks almost exactly the same as an @interface statement. Okay? @interface is where you put all your methods and properties that are public, or you can have an @interface at the top of your implementation and have private methods and protocol and properties, and the same thing for a protocol. It's just that you say @protocol instead of @interface. Now, a protocol is just a declaration of the methods. There's no implementation, so there's no implementation for an protocol. We're just talking about the methods, and the methods in a protocol by default are all required. Okay, so that means if someone wants to say that they implement this protocol, they have to implement all of these methods, and so those are all the methods in my little sample protocol here. You can make some of them optional by putting @optional in there. And now all the rest of those are optional. So now in this example, some method is required, but all the rest are optional. And you can put @required again, down a little lower. Now all of these are required except for method with argument is optional. Okay? So we're basically defining a little pile of methods, some of which are required and some of which are optional. Okay? That's what a protocol declaration is all about. Now you see how I've added x, y, z, z, y in angle brackets after protocol foo there? So what that says is if you want to say you implement protocol foo, you also has to implement all the required methods of protocol x, y, z, z, y, whatever that is. Okay? So it's basically a way of kind of like super protocol. It's not inheritance or anything, but it just kind of adds to the methods that is required by a protocol. And in fact, you can have multiple ones. So here's protocol is now requiring you implement the x, y, z, z, y protocol and a protocol called NSObject. Okay, now let's talk about this NSObject protocol because it's a very common protocol. You're used to the NSObject class, right? And NSObject protocol is basically a protocol that includes almost all the methods in the NSObject class. Okay, and why do we do this? Why do we have a protocol named NSObject and a class named NSObject? And they have pretty much the same methods in it. Is equal, is kind of class, description, perform selector, all those NSObject things. The answer is because we sometimes want to declare a protocol where some methods are required, but we also want to require the thing that implements the protocol to essentially be an NSObject. Okay, we want it to be an NSObject. We want to be able to maybe use introspection, things like that. Well, the only way to do that is to have the protocol have like a super protocol, you know, it's an additional protocol. And so we just took all the methods in NSObject, we put them all in a big protocol and have NSObject implement that protocol. Okay? So NSObject protocol and class, all the same methods, pretty much. Okay? It's just that NSObject, the class, is an actual implementation of those methods. So where do these protocol declarations, oh yeah, sorry, question.
In Java, all classes automatically inherit from object. Is that not the case with NSObject here?
Yeah, so the question is, in Java, all classes pretty much inherit from object, and that's not true in Objective-C. You could have a class where it just says @interface, name of class, no : superclass, in which case it inherits no methods from anywhere. Okay, we'll only have its own method. We never do that, however. In iOS, we always inherit from NSObject because we want the introspection and all these things. So, but it's by convention rather than by some sort of enforcement for the compiler. All right, so these @ protocol declarations of these methods, where do they go? They go in header files. They can go in their own header file. Okay, so I could have a foo.h for my protocol foo, or they can go in the header file of some related class, like some class that wants somebody to implement that protocol. You could put it in there. So, for example, iOS has scroll view class, right, for scrolling. We're going to talk about that next week. It has a protocol called the UI scroll view delegate, which is a bunch of will scroll, did scroll things, methods, and it's only good for UI scroll view, so that that protocol is defined in UI scroll view.h, not in its own header file. Okay, so you can kind of do whichever one you want, and you'll see them both ways. All right, so now we have the protocol declared. We defined this little bundle of methods, including the setters and getters or properties, perhaps. Now, some class has to promise to implement that protocol. And how do you promise to implement a protocol if you're a class? You just put angle brackets, the name of the protocol, on your @interface line. Okay? So here it's my public @interface line, and my class inherits from NSObject, angle brackets foo. That means my class is promising to the compiler and to readers of this code, I'm going to implement all the required methods in foo. Okay? So I'm just making that promise. And you can make the promise publicly like that, or you can make the promise privately by putting it in your @interface, my class, parentheses thing that goes in your implementation. Okay, you can just put it there if you want. That's if you only need to be able to implement that. You're only required to implement that protocol for something that's in your implementation only. Okay, not any public thing. Okay, so now I've got a protocol. I've got an object, at least one, that signs up to implement it. Now what? Well, now I can declare variables that are IDs with the additional requirement to implement the required methods of a protocol. So ID angle bracket foo obj, hopefully you understand what that means now. That means obj is a variable. It's an ID. I have no idea what class it is. Okay, it's ID. It's completely blind. However, I know it implements all the private or the required messages in foo. Okay, and it might implement some of the optional ones too, but I know at least the required ones. So if I say ID angle bracket foo obj my class alloc init, that looks good because on the previous slide I just said that my class promised to implement foo. So the compiler's going to love that. But if I said ID foo obj ns equals ns array, that compiler's not going to like that because arrays clearly don't implement the protocol foo. They don't implement those methods. Okay, so the compiler will warn you in that case. Okay, so the compiler here will warn you if you do this. It'll also warn you if you sign up to do a protocol, you promise to do something, and you don't implement the methods that are required, it will warn you about that too. Okay, so it'll warn you on both coming and going. In addition to declaring variables, like local variables under the examples there, you can also pass these around, these IDs that are modified by a protocol, as arguments to methods and as properties. Okay, so it's really just another type. It's not quite an NS string star where you know exactly the class and all the methods exactly that it does, but it's not quite an ID where you know nothing about it. It's in between, right? It's an ID, but you kind of know some of the methods in foo. Okay? Just like static typing, this is all just syntactic sugar in the compiler. It makes absolutely no difference at runtime. No code is generated any differently by the compiler because of these things. The compiler is just able to warn you now. That is the only difference. Okay, some people have a little difficulty accepting this, but it's true. No code generation is any different by the compiler because of these protocols. Same thing with NS string star versus ID. It's all exactly the same stuff gets generated by the compiler. It's just the compiler can warn you because they know what you intend. Okay? The number one use of protocols in iOS is delegation and data sources. This is back to, remember lecture 1, I had the MVC and I told you that the views could talk to their controller with blind structured communication. And we talked about will do this, did do that, or the data source, which is data at, count, that kind of stuff. All those, remember that communication? This is how we do that. So it's blind because they're IDs. The views are talking through IDs, but it's structured because there's a protocol that the view uses to talk to that object blindly so that it knows what's in there. So let's talk about, for example, the data source protocols of views. If it was a table view, let's say, a table view is a generic view for showing a table of information. Its protocol for accessing its data source is how many rows are there? And now give me the data at row 7. Give it data at row 500. Okay? That's its protocol, those methods, count and data at. It has other ones, but that's the base. Those are the basic ones. Okay? And we really need those data source protocols because views can't own their data. That table view can't grab all its data and display it. It has to keep asking someone else. But it doesn't want to be tied to any source of the data, so it wants to be an ID. It wants to be blind. Okay? And we'll see all this next week when we talk about table views. There are other uses of protocols besides that blind structured communication, and we're going to see one today, which is animation. And I'll let that speak for itself. But basically, we're going to have IDs out there that are animatable, and we're going to know they're animatable because they're going to implement a certain protocol. And that's how we're going to know that they're animatable things. And UI View is going to implement that protocol, and that's how we're going to animate our views. All right, the second Objective-C thing I want to talk about today is blocks. Okay, it's a totally different thing than protocols. Blocks, very important, used throughout iOS. In fact, I sometimes have difficulty getting all the way to week 5 here or 4 without putting blocks because it's so much in the API of iOS. What is a block? A block is a block of code. Okay? Why do we define this term block? Just to mean block of code. We already know that. It's because it's a block of code that can be embedded inside other code, passed as an argument, stored in an array. Okay? So it's a block of code that we manipulate and move around our API. So what does it look like? Here's an example of a method that takes a block as an argument. Okay? This is the calling of this method. This is an NS dictionary method. It's a real method. It's called enumerate keys and objects using block. Okay? The argument is a block that has no return value and takes 3 arguments. 2 of the arguments are IDs, which are the keys and values in the dictionary. And the third one is actually a bool star, a pointer to a bool. So it's a bool. It's an outgoing bool. Okay? And basically, when you call this method, dictionary will execute that block of code repeatedly for every key and value until you set the stop, star stop, to yes, or until it runs out of keys and values. Okay? And it's actually going to implement that code that's right there embedded inside that message call. You can see the open square bracket for enumerate keys and objects before a dictionary. The closed square bracket is down after the curly brace. Okay? So the code, the actual curly brace, we put right in there in the middle of our message call. Other languages, in computer science in general, we call this a closure. Okay? How many people know the name closure? Ever heard that before? Okay, so you guys generally know what this is. It's a closure. Blocks in Objective-C always start with the caret. That's the magic block character. And then there might be a return type possibly specified and maybe some arguments possibly, and then a curly brace and some code and an end curly brace. Now, of course, to make this really interesting, the compiler knows how to do things like have local variables that are declared before the block is used work inside the block. Okay? So if I had that block and I wanted to stop not just when I see the key enough, but also when I see the value, stop value, which is a local variable defined in the scope that's calling the method enumerate keys and objects using block, I can use it. The compiler makes sure that the value of that gets properly passed in. However, a question?
Oh, is this statically scoped for using things outside?
Yeah, it is the local, whatever scope the A dictionary enumerate keys and objects, that call, whatever scope there, that's the scope in which the variables can be used, which is pretty much the local stack, right? The stack from your thing. Now, those variables, though, are read-only. Okay, so if I had another one, a bool stopped early, and I tried to set that inside my block, that would be an error. Compiler would not allow that, okay? Because stopped early is read-only. However, there's actually a way to make it so it's not read-only, which is to put underbar block in front of it. If you put underbar block in front of a local variable, then the compiler will generate code that transfers stopped early off the stack into the heap so that it can be used by the block, and then when the block is finished, it'll copy the information back into the heap and then back onto the stack. Okay, all happens magically. So if you have underbar block, it knows to do that. So that's a little magic you put in there. Now your variables can go both ways. So now stopped early is yes is legal. Okay? This also works if the variable is an instance variable. We don't really access instance variables except for setters and getters, but that's because instance variables, of course, are in the heap, because all objects are stored in the heap. What about objects that are messaged inside of a block? Because there's a little special thing to think about there. So if I had a string stop key, which was enough, and I wanted to use stop key inside that block, like this, I have to make sure, well, not I have to make sure, the compiler has to make sure that it generates code, and the runtime has to make sure it works, so that stop key, that there's a strong pointer to it. Otherwise, it could leave the heap by the time this block executes, because this block could execute at any time. Okay? This block happens to execute immediately when you call this, but it's legal for the dictionary to grab this block and store it somewhere and execute it sometime later that it wants to. Okay? So every time you use it, listen to this carefully, every time you send a message to an object inside a block, a strong pointer is created to that object, and it stays around until the block goes out of scope, until the block no longer exists. Okay? As long as that block exists, a strong pointer to every single object in there, this message will exist. Before I talk about that, I want to talk about some shorthand. If the block has no arguments, like this block, see, no arguments there, you do not need to put the parentheses. Okay? You can just leave those off. And similarly, if the return value of the block, so this block, which is the first time you've seen a block with a return value, it returns a bool. See that bool? If the return value can be inferred from the contents of the block, right? So this case, return obj is kind of class UI class, definitely going to return a bool. You do not need to put the bool there. In other words, if it can be inferred, it'll figure it out for you. Okay? So just syntax, it's just to clean up the syntax, so you don't have to put the bool in there all the time, or whatever. Okay, now let's talk about how blocks sort of act like objects. Blocks are not objects, okay? They're not, but they sort of act like objects only in this really small way, which is they can be stored, okay? And they are reference counted by the automatic reference counter, okay? So storing them means they can be stored in variables, in properties, and in dictionaries and arrays. Okay? So they can be stored just like they're objects, but they don't understand any messages like an object. Actually, they understand one message, which is copy, which is kind of an important message because that copies them in the heap, and if you want to keep a pointer to a block around, you probably want to copy it, okay? So that it doesn't just go off the stack somewhere. So for example, here I am putting a block into an array. So I have a property in my class, myBlocks. It's a mutable array of blocks. And I just say self.myBlocks, add object, colon, a block. Okay? And I know this looks weird, and it is weird because blocks are not objects, but they act like objects for this purpose of storing them in things. Okay? So it's pretty neat. And by the way, I have not talked about basically how you would call this block. Like if I grab this block out of this array and wanted to invoke it, how would I do it? I'm not going to talk about that today, but I'm going to show you so that you can see it. Really, you're not going to have to do that in this class because you're going to be passing blocks to iOS and it's going to be executing them. But if you wanted to know, that's the syntax. It's kind of like C function syntax. You can look offline. I just don't have time to cover it, unfortunately. But there's a real danger lurking here, okay, in this code above, okay, this self-do something thing. And what is it? Well, it's called a memory cycle. How many people know what a memory cycle is? Okay, not very many. Okay, that's good, so I'll cover this. A memory cycle, it's caused because all the objects inside that block have a strong pointer to them as long as the block exists. Okay, so for example, in this code, self, a strong pointer will be held by that block to self. You see why? Because the block, as long as it stays around in that array, it needs to be able to call self do something, so it needs to always keep a strong pointer to self as long as the block exists. However, the problem is that self has a strong pointer to the block through its myBlock array, right? Self has a strong pointer to myBlocks, which is an array. The array always hold their things strongly. So now both of them are pointing strongly to each other. The block is pointing to self is pointing to the block. Neither of them can ever leave the heap in that situation because there's always going to be a strong pointer to them, each other's, right? One of them can't leave first and make it so there's no pointer to the other because they are keeping each other in. That's called a memory cycle. Okay? And we have to break these cycles. Hey, this is a serious problem. You definitely want to be able to break these cycles. And here's how we do it. We're going to do it with a local variable. Okay? Now, local variables are all what? They're all strong, right? Local variables are strong. They're strong pointers into the heap, pointer variables, until the method ends, and now the strong pointer goes away, and so now that local variable obviously is not holding something in the heap by being strong. But there is a way to actually create weak local variables with underbar, underbar, weak. Okay? Underbar, underbar, weak before a local variable declaration will make that variable weak. Okay? And remember that weak means it's not keeping the object in the heap. If no one else is pointing to it, it just goes away, and the weak variable gets set to nil. Okay? So I'm going to make a local variable, weak self, which points to self, but it's weak pointer to self. And now I can use that inside this block that I added. I'll send do something to weak self, and now I don't have this cycle anymore, because the block no longer has a strong pointer to self. It has a weak pointer. Okay? So yes, we will do this. You might have to do it in your homework, depending on how you decide to implement it, and I will definitely do it in the demo today, so you can see how this works. Okay? This is really the only place we have these kind of cycles with ARC, with the automatic reference counter. It's not too bad. You just have to know it's there and deal with it. Okay? Okay. So when do we use blocks in iOS? We use them for enumeration. You saw that dictionary enumerate keys and values. We use it a lot for enumeration. We use it for view animation. I'm going to do a whole rest of this lecture, and start of next lecture is going to be about that. We use it for sorting. There's messages you can send to arrays like, sort this array and use this block to compare two objects in the array. Okay? Notifications, right? When a radio station broadcasts, instead of sending a notification message, you can say, just execute this block when some broadcast happens on the radio station. Error handlers, very common. Do this thing, and if an error happens, execute this block and I'll handle it. Okay? Completion handlers, also very common. Do this thing that's going to take a long time, and it's going to be done in a background thread, and when it's done, execute this block to let me know. Okay? Animation does that. In fact, we'll see that in the animation too. Question?
So you have like a method defined in your class, and you want to use that function as a block. Is there any easy way to just refer to it, or do you have to like write it as a block?
Yeah, so the question is, if I had a method defined in my class or whatever, and I want to use it as the contents of the block, just call self and that method inside the block. And then that will call it. That's a common thing to want to do, actually. A very, very important use of blocks, which we're going to talk about later in the quarter, is multi-threading, okay? Which is getting your application doing multiple things at the same time. Not really at the same time, but seemingly at the same time. And I really encourage you, this is one of the few times I'm going to tell you, go look in the documentation to find out about blocks. Just search for blocks in Xcode documentation. And you can find out things like how to declare a local variable that is a block and things like that, because I haven't really talked about those things. Mostly I've just taught you enough about blocks to be able to call methods that take blocks as arguments. Okay, that's all I've pretty much shown you so far. Okay, so that's it for the Objective-C that I wanted to cover. And now we can get into the fun stuff, which is animation. All right? So that's going to be the rest of today and probably the start of Wednesday, because this demo is really big. And there's lots of different animation that goes on in iOS. I'm going to talk today, and really only in this course for the most part, about animating views. Okay? You know how to create custom views, right? And you could even animate non-custom views, buttons or whatever you want. But basically making views move around the screen, get bigger and smaller, fade in and out, spin around and rotate, that's what we're going to talk about, okay? Animating views. But there's other animation that goes on, like when you go into a navigation controller and you click and a new view slides in, okay? That's animation, all right? And it's possible also, okay, you're in the Maps app and you click in the corner and it curls up to show you other options. That's animation, okay? All that kind of view controller animation, I'm not going to talk about for the most part, okay? But that's all, there's all support for that as well. There's also a whole other thing in iOS called a collection view, which is a collection of views that kind of live in a grid, sort of, or in a flow kind of layout. And those all can be animated, what's going on in there as well. Okay, but I'm only going to talk about views. Underneath all of that is this framework called Core Animation. Super powerful framework. Okay, I mean, industrial grade animation framework there. But we're going to be doing it all at a much higher level, much easier to program, and kind of easier to. You don't have to know quite so much about the detail of how animation really works. Whereas core animation is really for animation, people who want to really do serious animations. And a lot of iOS applications are games or other things that have a very serious animation going on in there. By the way, in iOS 7, there's a lot of other things for doing animation. For example, SpriteKit is a way to animate sprites, which are essentially 2D graphic elements that are being composited in a way to try and create a 3D looking environment, like a lot of video games are. And we're not even going to touch SpriteKit, I don't think, unless we get to it the last week. So there's a lot of stuff that I can't possibly cover. So let's just talk the basics here of animation. So there's 3 ways to animate views, basically. Okay? The first way is that there are some very special properties in View, namely the view's frame. Remember, that's the rectangle enclosing it. Its transform, which we talked about briefly when we did the playing card thing. Transform is the view's scale, can be used to scale it up and down, and its rotation, the views can be rotated, and also translation, although usually for translation we use the frame, we move the frame around. And also alpha, its opacity. These 3 things can be animated at any time in a view, meaning you set them to a new value, and it'll set it to that new value immediately, but the effect will appear on screen animated over some amount of time. So let's take a look at how this works. It's done with a class method in UI View. Okay, a class method. It's not an instance method in UI View. It's a class method. And the class method basically takes the animation parameters, how long to take and stuff like that, and it takes a block. And inside that block, you can modify these 3 properties. There's actually a few others you can do, but these are the 3 main ones I'm going to talk about here. So it looks like this. It's called animation with duration. And the first argument is how long you want it to take for this thing to appear on screen. Remember that the change you make happens immediately. So if you change the alpha or the frame or the transform, instantly happens as soon as this method is executed. And this method returns immediately at all times. Okay? It does what's in the block immediately. But the appearance of it is going to happen over time, right? It's going to fade in if it's alpha. It's going to move over if it's the frame. It's going to rotate if it's the transform. Okay, that's going to happen over time. Duration says how long to take to do that. Okay? Delay is how long to wait to start doing it. And why would you want to delay? Well, because sometimes you want to chain animations. You want to do one animation first that takes 2 seconds, then you want to do another animation after that. Well, there's 2 ways to chain. One is to delay the second one, using this delay, second argument, or there's a completion block. You see the completion block at the bottom there? You can actually do another animation in that, because that completion block is called when the animation completes. All right? Options, we're going to talk about all the options. There's quite a few options for animating. And then there's the all-important animations argument. That is a block. You can see it takes no arguments and has no return value. In that block is where you change frame, and you can also change center and frame are related, and transform and alpha. Okay? So here's an example of calling it. Right? So I'm saying UI View class method, animate with duration. This animation is going to take 3 seconds. And what I'm going to do is whatever state my view is in, I'm going to make it fade out and disappear. Okay? So you see in the animation block, myView.alpha equals 0. That means fully transparent. Okay? So that is whatever it's at now. Okay? It could be anything. It's going to go from whatever it's at now to 0 in 3 seconds on screen. Okay? But in the code, this happens immediately. Immediately, the view has gone to alpha of 0. It's just that on screen, it's not showing what's currently the state. It's showing this animation. Okay? And notice the completion handler there. Okay? The argument to the completion handler's block is a bool that says whether the animation finished. Why wouldn't this animation finish? Well, some other animation might start animating alpha, or someone might just set alpha. So if anyone interferes with alpha, then the completion handler will get called. This animation will get interrupted. The completion handler will get called, but the bool there will be no. But if nothing interrupts it and the alpha goes all the way to 0, then this completion handler will be called and the argument will be yes. Yes, it completed. And if that happens, I'm then going to remove my view from the view hierarchy. So what this single line of code does is fades out my view, and if it successfully fades it out, removes it from the view hierarchy. Question?
If you, in the next line, did kind of the same thing except change the alpha to something else, and you had the delay equal to 3 seconds, it seems like it's right on the edge there. Maybe it happens after this one finishes, or maybe it happens before. Is there...
Yeah, so the question is, what if I have another animation that I execute on the very next line? Well, first of all, let's say I delay this one, right? So you're saying delay this first call, put the delay in there, delay equals 3 or something?
Actually delay the second one so that it happens.
Okay, so delay the second one exactly 3 seconds. Okay, so that'll be fine because the first one will finish instantly right before the second one starts, okay? Because it's a common practice to do exactly that. Have something take 3 seconds and then start the other one with a delay of 3 seconds. So yeah, it'll work. Here's another, I guess I didn't do that example. But anyway, so that is, everyone understand what's going on there? It's really that simple. The main thing to understand is that that alpha would be set immediately to 0. It's just on screen that it'll show. All right, let's talk about some of the options. The first one's an interesting option, begin from current state. So if you set this option on, okay, in the options list, what this means is if there's another animation that's going on that is animating the things I want to animate, then pick up from wherever they are when you do my animation. Okay? So if I'm doing that alpha thing and it's fading down and it's all down to 0.2 or something, and then I issue another animation to start that goes up to 0.7 alpha, if I have begin from current state option on, then it'll start at 0.2 and go up to 0.7. If I don't have this on, it'll start at 0 because 0 is what the real alpha is and go up to 0.7. So begin from current state is a way of intercepting other animations, intercepting them, right, in mid-flight. Okay? Because you need this because remember that when you set these animation parameters, it happens immediately. So if you want to intercept an animation on flight, you need some option for the system to go check and see where the view is if it's flying across screen before it sends it to a new place, or if it's fading out, it fades it to a new level. It's very common to have that option on, actually. And then you can see things like allow user interaction. Do you want to allow gestures to happen in this view while it's in flight? Sometimes that makes sense, sometimes not. Down at the bottom, you see those curves, curve ease in, curve ease out. Sometimes when you move a view across screen, you don't want it to just up and move. You want it to kind of slowly pick up speed, get up to full speed, and then slow down at the end. It's a little smoother kind of animation than just, here's my view, that's a little, you know, but okay? Better, smoother. So curve in, ease and out, that's for controlling that. Okay? Same thing for fading. You could do it for fading as well, though fading tends to be okay linear. But moving, definitely, curving in and out is a pretty good idea. So you can look in the documentation, see what all these options do. You can repeat animations, have them go over and over and things like that. So, so that's how you animate those special properties, okay? And it animates them. It figures out all the in-between. Even if you animate multiple of them at the same time, it's moving, it's fading, it's rotating. It'll interpolate all those points all the way along automatically. Okay, and pretty high performance as well. Okay, sometimes though, you're changing your contents of your view in a way that's other than those three things. The classic example here, the playing card. When I'm flipping my playing card over, the only property I'm setting in my view is face up equals yes, right? And now my card flips over to face up. Face up equals no. Now it flips over to down. So that's not an animatable property per se. However, what I'd like to do is have the view change from face up to face down through some animation, like flipping the card over or dissolving between the two. In other words, I want to change the entire view through some animation to a new state. And that's what this one is for, transition with view. So transition with view takes a view that you want to do, like a playing card view, and it takes a duration, how long it's going to take to go from the old state to the new state. Options, again, similar to the other options, but this is especially where you would specify the options listed at the top there, like UI view animation options transition flip from left would mean I want this to flip over or cross dissolve, and what's cross dissolve or curl up. And then animations, again, is a block. That's where you're going to set face up. Okay? In that block, you can set anything you want about the view to make it be in its new state. And the system will apply all those changes, redraw the view in the new state off screen, and then transition between the two. The old state that's on screen now and whatever your changes result in. Make sense? Questions about that? And then completion, same thing. If you get interrupted somehow, you know, it's harder to get interrupted on this one, but it can happen. Then the completion handler gets called, either way. Okay? So this one will be great. Part of your homework is to flip that card over, and this is the method you're going to want to use. All right? So very, very straightforward. If you're changing the view hierarchy, like you're swapping a view out, okay, you got a view in the view hierarchy and you're swapping a new one in, or if you want to hide a view in favor of another view, you can use this transition from view to view. So this one is kind of like the other one in that you're changing, but instead of having a single view that you're changing its state and then flipping it over, here you're replacing a view with another view. Okay, but otherwise it's very similar. It's even called almost the same thing, transition, right? Transition from view to view. Okay? All right. So that's it for direct changing of views, properties, and making things happen. Okay? The next kind of animation we're going to talk about, which is a totally different system, new for iOS 7, is called dynamic animation. And this one's a completely different concept. Here what you're going to do is define a bunch of physics that apply to all the views that you want to animate, and then you're just going to say, okay, do it. And they're going to go have those physics applied to them. So what kind of physics are we talking about here? We're talking about gravity, collisions, forces applied to them, things like that. Okay? And they're just going to keep on animating until the forces all balance out. Okay? And we'll see what that looks like. The way we do this is a really nice API, very easy to use. You create a UI dynamic animator. You just need to create one. You can do multiple, but this one, it's really for grouping these behaviors, but usually we create one dynamic animator with alloc init, basically. I'll show you that. And then you're going to add behaviors to it. Behaviors are like gravity, collisions, pushes, those kind of things. Those are behaviors, things that are going to be applied to the things. And then you put the things in there. And the things you put in there are UI dynamic items, meaning they respond or they implement that protocol. I'll show you that. And the instant you put them in there, they'll start animating. You don't have to say run. You don't have to do anything. They'll just immediately. Anytime there's an item that's in a behavior, that's in a dynamic animator, it will start animating until the forces on it mean that it doesn't need to move. Then it'll stop. Okay? So let's look at all these things. UI dynamic animator, you can just do alloc init, but when you're doing views, if it's views that you want to animate, you want to do alloc init with reference view. Okay, and init with reference view, you're specifying the top view of a view hierarchy. All the views you animate have to be in that view hierarchy. In other words, they have to be somewhere a subview of this reference view or a subview of that or a subview of that as deep as you want to go, but you have to specify the top level view. Okay? Then you create these behaviors. The behaviors are just alloc init, like UI gravity behavior alloc init, UI collision behavior alloc init, and then you add these behaviors to the animator using add behavior, which is a dynamic animator method. Okay? Couldn't be simpler. And then you add the items to the behaviors, and you do that with add item in dynamic behavior. So an item is just an ID that implements the protocol UI dynamic item, which you can see there below. And again, UI view implements that protocol. So usually the items we put in there are UI views about 90% of the time, 100% of the time in this class, 100% of your time in your homework. I'm only asking you to animate views. But you could animate completely non-visual items. They could be, as long as they implement this protocol, they can do anything they want. So what's in the protocol? There's the bounds. That's, again, the bounds in the items world. It's like the views bounds, right? It's its own drawing coordinate system. Notice that's read-only. Okay? It could be modified by the transform, centering, moving the thing around, possibly, mostly the transform. So the bounds, though, is just the drawing area for the item. But the center, in other words, the position of the item, and its transform, its rotation and scale, those are read-write. Those can actually be set. They're obviously set by the animator. That's what the dynamic animator does, is go figure out what the center and rotation and scale should be. And you can set them too, but if you do set them while the animator is also setting them, you have to call this method update item using current state in the animator, or otherwise the animator will ignore anything that's going on, okay? So if you want to be setting the center, if you want to be moving the thing while the animator is also trying to move it, in other words, you want to fight it a little bit, or if it's moving it and you want to rotate it, you need to do this update item using current state. Otherwise, it'll assume, for performance reasons, that it knows the current state until it's done animating, until everything settles. Okay? So that's it. Animator, behaviors, and items. That's all there is in this system. So now let's talk about some of these behaviors, the concrete behaviors that are available. There's gravity. Okay, gravity behavior by default, gravity is down. So if I'm holding my phone, it's down, which kind of makes sense. If I hold my phone up, I kind of want things to go down. But really, it can be set to any angle. You can have the gravity up or to the left. You can have multiple gravity pulling on things from different directions. In fact, if you had two things pulling, one from the top, one from the bottom, the thing would just float in the middle if they had the same magnitude of gravity. And you can set the gravity. A magnitude of 1 means 1,000 points per second squared. That's the acceleration due to gravity. Okay? That feels a lot like 9.8 meters per second squared, which is acceleration due to real gravity. So in other words, if you hold your phone up and let the gravity work, it kind of feels like it's falling about the same speed something in real life would happen. And it's also a very nice round number, 1,000 points per second squared. Okay? But everyone understand, it's just like gravity. It's an acceleration in a certain direction. Collision is really cool. Collision just means the items inside of the collision behavior, if they bump into each other, they'll bounce off each other, like a real-world collision. And you can specify the elasticity and how bouncy they are, and that even you can define the density of one versus another. So a really dense one will smash another one out of the way, all definable. You can also set boundaries. So any UI Bezier path that you want to come up with, you can put it in your collision behavior and things will bounce off it. So it could be round, it could be square, whatever, and things will bounce off it when they hit it. Also, you can set the boundaries of the reference view to be bouncy boundaries as well by saying translate reference bounds into boundary equals yes, and then things will bounce off the edges of the reference view, the top level view in the dynamic animator. Okay? So the collision mode determines whether the items bounce off each other or just off the boundaries. Okay? All right. Attachment behaviors. Okay, this is a way to attach an item to a fixed point or to another item. Now, one thing to remember about this, if I hook an item up to a point, that does not mean that item's not going to move. Okay? If I hook it up to this point and I have an item here, right, and gravity happens, my item's going to go like this. It's going to swing, okay? Because the attachment is just attaching the two things, the point and the item. It's not attaching it to the background, okay? And also, if I move the point, the thing will stay with it, and it'll kind of swing around behind it. And we'll see this in the demo, okay? So attachment is attaching the thing to a point. You can also attach two items. If I attach two items like this, and I have gravity down, they're going to go bam. They'll stay the same distance apart, but they're just going to go straight down because gravity will still be applying to them as well, right? And the connection just keeps them together. The attachment behavior is a little different than the other ones in that you don't alloc init. You actually specify the attachment at init time. So alloc init with item, alloc init with other item. There's also some versions where you can attach items where the attachment point, instead of being the center, is offset. And that will make things kind of hang. If the items rotate, they'll kind of tilt, okay, because you're not grabbing them in the middle, you're grabbing them on the side. So you can make some pretty cool effects. The other thing to notice about attachments that's cool is that the length between the two items is writable. So, for example, let's say you were pinching, okay? You could change the length, and those two attached items would move closer together, okay? So even though you set it up as this item attached to this point, or these items attached to each other, if you change the length to be smaller, they'll move towards each other. Okay, which is cool. And same thing with the anchor point. If you move the anchor point around, the attachment will still there, and the thing will follow around, right? with other behaviors applying to it. Question?
Is that attachment length? Is that an exact value, like it would be with like when they're attached?
Is it like an iron bar, you mean?
Yeah, like iron bar or string.
Okay, so the question is it like an iron bar or is it more like a string? And actually what it is, it's like a spring. Okay, so it actually, as you move it around, like if I move it up, it'll spring up. And you can control the damping and oscillation of that. By default, it's an iron bar. Okay, so the damping and oscillation are set so that it does not oscillate. But you can set it so that as you follow around, it kind of, it's really very cool. So you can play with all those when you are doing your homework. Snap behavior snaps an item to a location, but it does more than just have it fly there. It does fly there rather rapidly, I might add. When it gets there, though, you can imagine that there's 4 springs attached to the item in the corners a little ways out. And so the thing gets there and it goes, kind of springs like this. And you can specify how much it does that. Why does it do that? That's because you want to give feedback to the user, oh, I just moved this. And so you don't want it to just go, blip. You want it to go, you know, and it kind of gives them just a moment's springiness. So, oh, okay, so that's good in animation. So snap behavior, very common. Also, you have push behavior, which is you can push an object and it'll start moving. So especially if you don't have gravity, this might be what causes things to move. You push it and it moves across. And these items have friction. They have density when they collide with each other. So push, you can read about push and how you specify the angle and the magnitude and all that. Okay? So, another thing about behaviors is you want to be able to set this friction, elasticity, the density, all these things I was talking about. You want to set them on the items independent of the other behaviors. Okay? So, if I have friction, I want it to apply whether it's gravity that's causing the thing to move or whether a collision caused it to move. So we don't put the friction and the density and stuff like that in collision behaviors or gravity behaviors. We put it in its own behavior called the items behavior. So there's a class, a behavior called UI dynamic item behavior. Okay? And so if you want any of these things, like you don't want to allow it to rotate, you don't want the view to be able to rotate, which I don't know, for your homework, sometimes you might want that, sometimes not, or you want to specify the friction or the bounciness of this object, you create a UI dynamic item behavior and add the items to that as well. So the item would be a member of the gravity behavior, it might be a member of the collision behavior, and it's also a member of a UI dynamic item behavior. Okay? And this controls all its options. So you can think of this as kind of like the animation options, but really it's more like the behavior of the intrinsic behavior of that item. Okay? What is its density? You want that to be the same no matter what behavior is acting on it. You can also find out information about what's going on with the item using the UI dynamic item behavior. It has methods like linear velocity for item. It'll tell you the velocity of this item in different directions, which is really cool for if you want to take over animation. The dynamic animation system started this thing moving, and now you want to take over and keep it moving, maybe in some other direction or something like that. You can find out how fast is it moving right now and then continue having it move at that speed. Same thing with angular velocity, how fast it's rotating in radians per second. Okay? Dynamic behaviors also, UI dynamic behavior is the base class for gravity behavior, collision behavior, all these. You can also create your own subclass, and usually when you do, your implementation just adds other behaviors as child behaviors. So there's a method in UI dynamic behavior called add child behavior, and you can add a gravity, collision, UI dynamic item behavior as sub-behaviors. And this is very common to do just to clean up your API, to group behaviors that go together into their own class, okay? Their own UI dynamic behavior subclass. And all that thing usually has is child behaviors and then maybe a little bit of API to add the items in a certain way or have them interrelate in some other way, okay? What is more, all behaviors, all UI dynamic behaviors, gravities, collision, your own custom ones, whatever, they know what dynamic animator they are in. They have a property called dynamic animator, which is say what dynamic animator they're in. And there's kind of a view controller lifecycle thing of UI dynamic behaviors, which is only has one method in it, will move to animator. So that gets called every time it gets moved to an animator or out of an animator. This will be called with nil. Okay? So that way you can find out whether your behavior is currently being animated or not, and by which animator. Okay? And the last thing I'm going to tell you about behavior is really cool property is a block called action. This block returns nothing and takes no arguments, so it's a basic block. This block you provide, you just say my whatever behavior, gravity behavior, collision behavior, whatever, dot action equals a block. It will execute that block every time this behavior causes animation change. Okay? So this is called a lot. As gravity pulls the thing down, every time it moves, even a pixel, this thing gets called. Okay? If a collision happens and it moves off, that causes it to move, this will get called. Okay? So this is a way to get in there and get involved. Now, you have a responsibility when you get in there. Don't do anything really expensive in action, or your animation will get all jerky. Okay? You do not want to do something expensive like draw too much, but you can draw a little bit. And we'll show in the demo on Wednesday, we get to the part where I'll set an action that draws a little bit so that we can see things a little better. And you can see that it's really nice to be able to set this. Okay? So this is this simple little hook to get involved with the animation that these behaviors are causing to happen. Okay? All right, so let's do this demo. All that what to look for, you can look on later. Just make sure that you actually saw this. This demo is called Drop It. I'm basically going to drop views, squares, down, and they're going to collect at the bottom. And when a whole row collects, I'm going to blow them up. Kind of like Tetris. You know, Tetris, you put the blocks in and they fit, and when you get a row, boom, the row disappears. We're going to do that. Okay? We're not going to use Tetris squares and stuff like that. This is a demo. I only have 45 minutes to do, but we'll do blocks instead. But the main thing, I just want to show you everything I can in that amount of time about animation. So we're going to make a new app here. Let's get rid of that. Don't need that. We're going to create a new project. I'm going to call this project. I'm going to go quite fast now through most of this stuff that you already know how to do. So I'm going to do drop it. I'm going to call the view controller also drop it. Okay, we'll put it in home directory developer. Here's our drop it. You know me, I always like to move these out of the way. All right, so here I have my storyboard. I'm going to use a generic UI view to contain my game, okay, my little dropping game. I could do all this dropping in self.view here, but that's usually a bad idea, because what if I ever want to add a score or another button or something like that? I want my game to then be in a little smaller space, and you're going to want to do that for your homework as well. So I'm just going to drag out a generic UI view. I always have trouble finding it. Yeah, there it is. So I'm going to drag this generic UI view in here, and I'm going to create an outlet to it. I'm going to call it my game view. So I'm just going to control drag out here. I'm going to call it game view, and it's a generic UI view. It's no custom thing, but I just want it to be the bounds, and I could move these bounds in from the edge if I wanted to put some other UI in there or whatever. So now I have my game view, and I'm also going to have a tap gesture. So let's drag out a tap gesture so that every time I tap on this, I'm going to add another square to drop. Okay? So I'm going to put this on my game view. Here's my tap gesture right here. Control drag this out. I'll call it tap. Okay, connect. Make some more space here for us. So every time that you tap on my game view, I am going to drop another little square that falls down like a Tetris kind of thing. Oops, drop. Okay, so that's what this method is going to do. It's just going to add a view. So this is also a chance for me to show you how to create a UI view in code, which hopefully you've all done that because you've done the part of the homework that's the custom view. But if you haven't, here you go. I'm going to actually create the frame first. So I'm going to do this frame. I'm going to have the frame's origin start out as CG.0, but then I'm going to change the X origin. So I'm going to have that drop start out at the top, and I'm just going to put it at a random spot across the X. The size, I'm going to define a nice little, let's do a static const CG size. We'll call this drop size equals, and I'll make it like 40 by 40, but I'm going to make this be a static const as opposed to making it be a property or something, because I don't want to write the code right now to deal with the fact that someone changes this, because I'd probably have to redraw my whole thing to have smaller squares, right, or something like that. which is cool, would be great to do, but it's just time constraints. I'm not going to do that. So I'm going to have the frame size be this drop size, so that I'm creating a little drop view, okay, and that's the size I want it to be. So here I'll do my random, actually let's go ahead and do this. Let's go to here. Let's go just pick a random place along the x-axis. So I'm going to do arc4 random, and we're going to mod that by the self.gameView.bounds.size.width, so somewhere along some random spot along there. And I'm also going to make it be lined up so the drops are, in a grid. So I'm just going to divide by the drop size.width, and then I'm going to multiply by saying, oops, frame.origin.x equals x times the drop size.width. So you see here, I've divided it here. This is an int, so it's basically going to do a floor, right? I've picked a int, and then I just multiply it back. That puts it at a random spot across. And then I create a view just by saying drop view equals UI view alloc init with frame, which is the designated initializer for view, and I'll specify this frame. And then I'm going to set the drop view's background color to be a random color. Okay, I happen to have a little snippet here for that, random color. Okay, so random color just picks one of 5 random colors, okay, right here. And then let's just go ahead and self.gameView, add subview, drop view. Okay, so it's as simple as that to drop something on here. So unless I've forgotten something or doing something wrong, let's go ahead and run. And every time I tap, we get another one. So that's great. So they're collecting at the top. That's nice. Now we're going to add some gravity so that they fall down. Okay, animated, right? So they fall down. So how do we do that? Very simple. We're just going to create an animator. Let's go have a property which is strong non-atomic, which is a UI dynamic animator. And I'm also going to have a property which is strong non-atomic, which is a gravity behavior. I'll call it gravity. I'm keeping these names short kind of for a reason, but you might want to call it gravity behavior. I'm going to go ahead and do some lazy instantiation here. So let's get our dynamic animator. If not animator, then I want to create one. Otherwise, I'm going to return it. Okay, so as I said, when we create the animator, it's just UI dynamic animator alloc init with reference view. And the reference view is just our game view, right? That view that I dragged out, that generic view. It's perfectly fine for that reference view to be a generic view. And then the gravity one, similar kind of deal. If the gravity is not set, then we'll create it, and we'll return it. And creating a gravity thing is very simple. We just say on gravity equals UI gravity behavior alloc init. Okay, I'm going to do one other thing here too, is I'm going to say self.animator add behavior. Okay, so anytime someone asks me for the gravity thing, I'm going to add it to my animator. But this is only going to happen once, right, because it's my lazy instantiator. So that's good. That's exactly what I want. I could also in here set things like the gravity's magnitude, right? So I could say, light gravity instead of 1.0, a little lighter or whatever. Okay? So now I have an animator. I have a gravity behavior. All I need to do now is add this drop view, okay, that I created to that. So I'm just going to say self.gravity add item, my drop view. Okay? So now that the instant I do that, it's going to start animating. So let's take a look at that. So you can see as I click, they immediately start animating. Okay? And, sorry. And, but they're falling off the bottom. Okay? So that's not so good. I want them to stop at the bottom. So to do that, I just need a collision behavior. Very easy. Just go up here. Property, strong, non-atomic, UI collision behavior. Collider, I'm going to call it. and my collider, if my collider's not set, oops, then I'll set it. Turn the collider. I really should have a snippet for that kind of thing. I think Johan showed that in this Friday section. So that equals UI collision behavior, alloc init. And here I'm also going to set the bounds, oops, to yes. So I'm going to have this collider use the bounds of the reference view as its bounds. Okay, so it's a one-line thing to get that in there. But I could make, you know, a nice UI Bezier path, you know, like down on the bottom, whatever I wanted. But then it suits my purposes here just to use the whole translation thing. And I'm going to do the same thing here, self.animator, add behavior, this collider, okay, so that it gets added to the animator. So again, I need to add any items that I want to be affected by the collider to the collider. And now it's going to, as soon as I do that, if something hit it, it would start colliding. All right, so let's take a look at that. Okay, so hopefully they drop. They bomb. Notice they have a little bounce to them, a little bounce in their step. Okay. Now notice that they tilt a little. Okay, why does that happen? Well, on the way down, okay, the two, they landed, one was bouncing and the next one hit it, and there was a little bit of real world bounce to it. Now, probably if we're building a Tetris game, we don't want them to rotate and get off center like that. So we would have to, A, not allow rotation probably, and B, we might want to grid them up. And I don't think we're going to get that in the demo, but maybe on Wednesday after we get to that, I'll post how you would actually do that. Okay, and all we're going to do is when they collide, we're going to have them line themselves up. Okay, so we'll do that later on Wednesday. Okay, notice that I have these two very related behaviors, gravity and collider. They really go together. Okay, so this is where I might want to create a custom UI behavior. So let's do that real quick. So I'm just going to go File, New File, okay, New Class, and this class is going to be a UI dynamic behavior, and I'm going to call it the drop it behavior. Okay, and that is going to be a new behavior I'm creating that's going to have the gravity and the collider, and eventually some more things, as child behaviors. Okay, so let's just hit next. It's where it wants to put it. This is all good. Here it is. Okay, here's my drop it behavior. And all I'm going to do in this drop it behavior is I'm going to define a couple of methods here. Add item, which allows you to add a UI dynamic item. Notice that I'm using this protocol syntax. And then I'm also going to let you remove an item. Okay, and that's all I'm going to implement in my drop it behavior, except for I'm going to override its init. Okay, so what am I going to do in its init? So instance type init. I'm going to do self equals super init. So that's UI dynamic behaviors init. Oops. All right, and then return self. And then in between here, all I'm going to do is add child behaviors for the gravity and the collider, which I'm actually going to copy and paste to save ourselves a lot of time. Here's a nice little lazy instantiation of these. And let's go grab the, oops, let's grab the outlets for these. Grab those. Oops, sorry, I keep clicking on the wrong button on the right. Okay, so this is @interface, drop it behavior. Oops, paste, hello, paste. End, okay, so we got those, that's good. These lines, we're not going to add it to the animator because we're going to add this whole behavior to the animator, so we can get rid of those. And in add item, which we'll put right here, actually let's go ahead and copy and paste these two things that we want. Add item and remove item. Okay, all I need to do here is add them to each of my sub-behaviors. So I'll do add item to my gravity and add item to my collider. And I'll do the same thing for remove. Okay, except for we want this to be remove. Okay, so this is a common pattern here. You create basically a dynamic behavior that it has child behaviors, and in the add item, you might also have add items, you might have init with items, whatever. And then here we're going to add child behaviors, the gravity, and the collider. Okay? So we've created a new class here. It's a subclass of UI dynamic behavior. We can add items to it, just like we added items to our gravity and our collider. And its implementation is merely to have these little sub behaviors. Okay, very, very simple. And when we go back to our controller here, we need to, instead of having the individual ones, now we're just going to have a drop it, # import, drop it behavior. We're just going to have a drop it behavior. Okay, we'll put a little lazy instantiation for this one too. Oops. So there's alloc init. That's going to call that other init that we just did. We'll do self.animator add behavior, our drop it behavior. Right? And then we'll just return our drop it behavior like that. And now down here, we don't have to add these separately. We're just going to say drop it behavior, add item, like that. Okay, so everyone understand how we kind of grouped all that stuff over there? And we're going to add more things as this demo goes on to this kind of general drop it behavior, and we're going to add them over in that other class now. We're still going to add other behaviors that we add here that really aren't part of that other thing, but now we've at least collected that into a nice space over there. So hopefully that didn't break anything. Let's see, it didn't. Okay, it's all still working, which is awesome. So now what I want to do is, when I get a full row like that, I want it to blow up. Okay, and I'm going to do the blow up not using a dynamic animator. Okay, I'm going to do that with that UI view animation business, because I want to show you how you can mix the two together and they'll work fine. Okay, so let's do that. So how are we going to do that? Well, one question is, when can I start thinking about doing other animation when I've got this dynamic animator going off and doing all these things, bouncing and colliding and all that stuff? And the answer is, you can find out when an animator reaches quiescent state, when nothing's bouncing, everything is resolved, okay, when it's quiet. Okay? And you do that using a delegate for the animator. So if I go to animator here, there is a property on animator called delegate. And the delegate is an object that's going to find out when the animator stops and when it starts up again. And I'm going to set that to be self. Now when I do that, I'm going to get a warning from the compiler here. Why is that? It says you are assigning self, which is a drop it view controller, to something that's supposed to be an ID UI dynamic animator delegate. In other words, you're supposed to be implementing this UI animator delegate. So we have to go up here and say that we implement this UI dynamic animator delegate. This is what we were talking about, protocols, saying that we promised to do something. Okay, now I'm not getting any more warnings, so there must not be any required methods in this. They must all be optional. And in fact, they are all optional, and there's only 2 of them. And the one I want is called dynamic animator did pause. You can see there's the 2 dynamic animator delegate methods, dynamic animator did pause and dynamic animator will resume. Okay, so that's telling you when it reaches a settled state and when something changed, a behavior or an item got added, and now it's going back active again. Okay, so in this case, we want to know the pause. Okay, when the pause happens, I'm going to look at that bottom row and see if it's complete. Actually, I'm going to look at all the rows and see if any of them are complete. Okay, and if they are, I'm going to blast them out of there. So I'm going to do that by calling a method called remove completed rows. And I have a little snippet for that to speed us up here. Okay, here it is right here. Okay, I didn't put it all in here. Actually, remove completed row, I called it, but really it should be rows. So how does this work? Well, you can take my word for it that this little snippet of code, and you can go look at it later, it basically just fills this mutable array, drops to remove, with all the drops that are in a completed row, even if there's multiple rows. Okay? It does this using this method hit test. I'm actually looking at all these things and seeing if there's a view there, and if it is, I'm okay. And if I get all the way across a row, I'm like, okay, I got a whole row, and I'll keep them all. So that's what drops to remove. This code right here is going to fill in drops to remove with all the things. Okay, so now we have an array of the drops that we want to remove. Now let's talk about what we're trying to learn here, which is animation. How do I remove them? And what I'm going to do that, it's kind of a two-part deal here. The first thing I'm going to say, if I have any drops to remove, okay, then I am going to remove all of the drops that I'm going to be taking out of this view from the animator, from the dynamic animator, because I don't want the dynamic animator fighting me, okay? I'm going to remove these things using UI view animation. I don't want it trying to pull them back or the gravity pulling on it. So I'm going to take them out, and I do that very simply by just saying self.dropItBehavior, remove item, drop. Okay, so I'm going through all the drops to remove, and I'm removing them from my drop it behavior. Now they're not in any behavior, so they're not going to be affected by the animator. Okay? Now I'm going to, so that's that. Now I'm going to animate the blowing them up. Okay, and I'm going to do that with animate removing drops, drops to remove. Okay, so this is a new method that we're going to write together here. Animate removing drops. It takes an array of drops to remove. Okay, and how are we going to do this? Well, I'm just going to do UI view, animate with duration. Okay, so I want, there's a few versions of this. Some of them have delay, some don't have delay. So I want the one, which one do I want? I think I want the one with just completion. So that's this one. Okay. So I want this one right here. How long is it going to take? I'm going to take about a second to blow those things up. This probably wants to be a constant, and you want to tweak it to look good, right? If it blows up too slowly, it looks ridiculous. If it blows up too fast, people can't tell that it did it, so we'll do that. And then here's the animations, which is just a block. And here's the completion, which I'm not going to do anything on complete. Actually, I am going to do something on completion. Let's do something on completion just to show here. So finished. Okay. And that's it. So that's this entire animate with duration. All we need to do is fill in these two blocks. All right, so let's do this block first. This is the animations. This is the actual moving. So all I need to do here is move these things out of the way. So I'm going to have them kind of explode up and off the top of my view. So I'm going to move each one to a random location somewhere off screen above my view. Okay, kind of just out there somewhere. And so I'm going to do that by saying for UI view, drop in, drops to remove. I'm going to have the X be some random location that is between 2 times my width to the left to 2 times above my width. So it's going to be kind of going out like this in a funnel. Okay? So the X has to be from 2 times my width to the left to 2 times my width on the right. So I'm going to make that be self.gameview.bounds.size.width times 5. Okay, so that's going to get me there, minus self.gameview.bounds.size.width times 2. Okay, and actually I'm going to move this all back here so we can see it better. Move this back too. Okay, so let's even do that. Okay, so you see I'm just going 5 wide and I'm shifting it over 2. So I'm just creating this thing above. And then the Y, I'm going to make Y easy. I'm just going to have it be self.gameview.bounds.size.height. And then when I move it there, I'm going to make it negative. So I'm going to say drop.center equals CG point X comma minus Y. All right. So inside this duration block, if I change the center, it's one of the magic things, this will get animated. Okay, center and frame and alpha and transform, those are all the magic things that automatically will animate. And what did I type wrong here? Drop. Oh, CG point make, yeah. Make. Good job. Okay, so that's it. So now they're all going to blow up. What am I going to do in completion? Well, after they blow up, if they successfully blow up, I'm going to remove them all from the super view. right? Because I don't want them anymore. I just blew them up. They're gone. So what's a cool way to do that? Watch this. Let's go drops to remove, make objects perform selector, @sign selector, remove from super view. Okay, I told you that methods like this would come in familiar, it would come in handy, and they are. It's better than having to do for, in, all that stuff. Boom, just do this. It's going to send remove from super view to all of them. Okay? Make sense? All right, let's see if this works. All right, so let's add some of these guys until we get a whole row. Oh, almost there, almost there. Oh, come on. There it is. Okay, now, two things there. Notice that we got the animation of the thing happening, but what happened to all the other blocks? They moved down because they're all still under the influence of the animator. Gravity is still pulling on them. The collider is still working. So if I put a whole bunch of things in here, okay, and also, okay, they're kind of tilting. Watch this again. Oh, let me see. Yeah, I did. I did get unlucky with the hit test there. Here, let me show you a different way. The hit test is kind of a questionable way to do that, by the way. But here, let's show you. I'll just show you this, doing this again. Also, I should make it so that they're not tilting like that. We'll do that next time. But wow, I'm getting unlucky. There we go. Okay. Hello. Knock, knock, knock. Okay, well, I don't know why that's not working now, but anyway, you got to see it working, and time's up. But we'll look at that. We'll look at that later and try and find out what our problem was. But anyway, the main thing there, notice we did the flyaway, but we also had the animator still working on the other things. And that's important to know that the two things can interact like that. If you move things out of the way, the animator is going to go back to life and start pulling down on things, okay? So next time we'll continue to do the animation. We'll make it so that it's not so rickety, okay, so that we don't have this problem where the bottom low doesn't line up. And we'll also do an attachment where we attach to something and have it swing from an attachment with a little attachment behavior. All right, we'll see you next time.
For more, please visit us at stanford.edu.